All right, we are moving on to the second part of the notes here. So if you have not already done the front side of Coulomb's law, go back and do the first video first and then come back to this video. So down here, we are going to be learning about something called the inverse square law. And to start it off, I'm just going to do a quick rewrite of the equation we did in the previous video. So that was the force is equal to K Q1 Q2 divided by the distance squared. And when we say inverse square law, what we're really focusing on is this distance squared on the denominator. So this means that the force is going to drop off really quickly when the distance is changed. Now, we should know from like third grade that when you divide numbers, you're making them smaller. And when we divide by a number squared, that's going to do something interesting to the math. So what we're going to do here is create a proportionality, something we haven't really done a ton in this class. So the force, instead of writing out the entire equation, we only really care about this distance squared. So instead of doing an equal sign, we're going to do this symbol, which just represents that it's proportional to. So the force is proportional to. We're going to take that KQQ that was up top, and we're going to simplify it into just a 1. Because all we care about is that distance squared. So the force is proportional to 1 divided by the distance squared. And we're going to see why this particular form of the equation is helpful in just a second here. So let's do example 1 together. So two positive charges repel with a force of 18 newtons. And we want to know how much force they enact when the distance between them is tripled. Okay. So when we say tripled, that means that our distance is getting multiplied by 3. So in this case, what I'm going to say for tripled is that D is equal to times 3. Okay. When we write that as a proportionality, if we were to do 1 divided by 3 squared, you'll notice that it becomes 1 divided by 9, because 3 squared is 9. So what we're going to do, we have 1 over 9. We need to take our 18 newtons and multiply it by 1 over 9. So 18 newtons is what we started with, times 1 over 9, because we tripled the distance. And those of you that are good with math can see that this is just doing 18 divided by 9. Showing my work here, if we were to multiply across the numerator, we would have 18 newtons divided by 9. And we can do this part in our head. 18 divided by 9 is just 2 newtons. And so we can box that up as our final answer. Notice that this required a lot less numbers to be plugged in than before. All we needed to know is what happened to the distance, and we could tell what the new force would be. So this type of problem can be a little bit tricky. I will do one more example with you before we have a try it on your own. So example 2, we've got 2 negative charges, and they are repelling with a force of 16 newtons. And we want to know how much force they enact when the distance between them is halved. Okay. So if you think about cutting something in half, what this is doing, instead of doing times 3 like we did in example 1, our distance is being multiplied by 1/2. Okay. So when we do our 1 over d squared, so 1 over d squared, if we were to plug in 1/2 to this, we would get 1 divided by 1/2 squared, which is going to be really weird for us. Okay? When we do a fraction like this on the denominator, what we need to do is flip that denominator, so that 2, is getting flipped up to the very top. So when you do a fraction of a fraction, it flips it around. So instead of being 1 over 2, this is going to become 2 over 1 squared. And if you haven't seen this in your math class yet, then this would be a good topic to call me over for a little bit of extra help on. 2 divided by 1 is just 2. So we're getting 2 squared, which means we have a factor of 4. Now, a lot of people will just answer with this number, 4. But remember, we need to take into account that original 16 newtons that we started with. So we have 16 newtons. We're multiplying it by 4, and that's giving us our grand total of 64 newtons. I'm going to box that up as my answer. So what I want you guys to do is try it on your own section on your own. If you need help, now is the time to ask. After this set of notes, there is a worksheet on pages 3 and 4 for you to work on before we get to the mastery check today. So if you have questions, let me know. I'm probably walking around the room. And besides that, good luck with pages 3 and 4.